A supernova signals a star's death throes. Having exhausted its fuel for nuclear fusion, the star collapses, producing a gigantic explosion of matter and energy that can be seen from 10 billion light-years away. The supernova shines for a few months, then fades. All that remains after the cosmic light show is either a dense, smoldering core, called a neutron star, or a gaping black hole. At least, that is what's supposed to happen. Some 500 million light-years away, in a galaxy so distant it looks like little more than a smudge, a star exploded 5 times over the course of nearly 2 years, spewing the contents of 50 Jupiters and emitting as much energy as 10 quintillion suns. This isn't even the first time the star has gone supernova. Astronomers believe the same body was seen exploding 60 years ago. Somehow, this zombie star has managed to survive one of the most powerful, destructive events known to science, multiple times. It should make us question, researchers wrote Wednesday in the journal Nature, how much we really know about supernovas. The discovery was made by scientists working on the Intermediate Palomar Transient Factory, which uses a telescope near San Diego to survey the night sky for ephemeral events like supernovas. Ir Kavi, an astrophysicist at the University of California at Santa Barbara and Las Cumbres Observatory who worked on the project, was mainly interested in stars in the early stages of explosion. So, in September 2014, when the survey captured a fading supernova near the constellation Ursa Major, he didn't give it much thought. The event looked like a garden-variety star well on its way toward oblivion. 5 months later, an intern who had been assigned to look over old data asked Arkavi to look at something weird. The intern pulled up a plot of the supernova's emissions over the past 137 days. Bizarrely, the explosion was getting brighter. Figuring that this must be a fluke, maybe just a star in our galaxy twinkling weirdly, Arkavi broke the light from the explosion into its component wavelengths. This spectrum contained all the signatures of a supernova. Even stranger, it looked like a nova that was only 30 days old, though the scientists had concrete proof that it had in fact been going on for months. That's when it became very puzzling, Arkavi recalled. The event, dubbed IPTF-14HLS, was put on 24/7 watch. The eyes of the Las Cumbres Observatory, a robotic network of telescopes positioned all over the world, followed the supernova as it brightened, then faded, then brightened again. The nova hit 5 peaks of brightness before finally seeming to dwindle in summer 2016. But at 600 days old, it was already the longest-lived supernova ever observed. Meanwhile, one of Arkavi's colleagues started searching astronomy archives in the hopes that someone else might have observed this renegade explosion. It turned out that the very same Palomar telescope had examined this portion of the sky twice before, in 1954 and 1993. No supernova was visible during the more recent observation. But in 1954, there was a noticeable bright spot in the galaxy that's home to IPTF-14HLS, another supernova. Because the galaxy is so distant, Earth-bound telescopes can't distinguish the light of individual stars within it. There is a small chance that the 1954 explosion is a coincidence, another star that happened to blow up in the same galaxy. But given what astronomers know about the frequency of supernovas, Arkavi put this possibility at no more than 5%.